AP confidence interval videos coming from chapter 21. We're going to start by talking about the distribution of a categorical variable for proportion. So basically this, we already talked about a sample proportion, how to get that and how to interpret it, but what's a distribution look like? And that brings us to something we've already discussed a little bit, and that is a normal curve. So if we take a sample of the population, typically like height for example, we get a normal distribution where we might have an average height, let's say 5'5" or 5'6", or so many inches tall. But we might get some taller people and then some shorter people, of course we will, but you have the main group of people in the middle. And then they go by standard deviation, and standard deviation is a measure of spread. So maybe standard deviation could be 2 inches. So this person would be 5'7". This next deviation up would be 5'7". And you go by 2 inches, and those are standard deviations. And then you can go shorter as well. So this would be 5'3". So notice what we're doing is we are adding 2 inches and subtracting 2 inches as we go. And with a normal curve, there's a rule that goes with it for approximations, and that is that if you go 1 standard deviation away from the average for a large population, the rule states that you can be pretty sure that 68% of the population is within 1 standard deviation above and below the average, or the proportion. If you go 2 deviations out, this population from here to here is said to have 95% of the population. And if you go 3 standard deviations out, that's said to have 99.7% of the population. Sorry for the handwriting, but hard to use my pen on this, so bear with me. So we have a 68, 95, 99.7 rule, basically. The 95 should look a little familiar when we do confidence intervals, and that's going to come into play with our questions a little bit later. The application of this is going to come to you in question 20.3 when we standardize it. So for example, if I have ACT scores that has a certain distribution, and I have SAT scores that has a certain distribution but different scores, because I think in ACT you may have an average of a 20 or a 16 or who knows, and a SAT might have an average of like 1,000 or something like that. They have a much different scale. How do you compare the two scores? So we do what's called standardizing it, and that calculation is brought up in 20.3, and to do that is to take the p-hat that you get, you subtract the proportion of the population and divide by the standard deviation of the population. The unique thing about this is we rarely know those two things because we're always seeking them, especially the parameter of proportion. But in some questions they give it to us, or like for the SAT and ACT, they know it after they're done, so they can go backwards a little bit and compare it. So sometimes they give us those things.